Good morning, students. In a previous class, that is class 2 of the chapter Basic Concept in Chemistry, I will cover the little idea about atomic mass, molecular mass, and equivalent mass. What do we mean by atomic mass? What do we mean by mass of one atom? What is a gram atomic mass? What is a molecular mass? Gram molecular mass. What is equivalent mass? How we calculate the equivalent mass of an acid, base, salt, ion. These are equivalent mass of metal by different methods. It is better to recap a little bit. That means mass of an atom represented in a gram, 1 term. Gram atomic mass, 1 term. I repeat again, never confuse atomic mass and gram atomic mass. Atomic mass means mass of one atom. Gram atomic mass means mass of Avogadro number of atoms. For example, if we select one example, that means oxygen atom, atomic mass, that means mass of one oxygen atom is 16 AMU, atomic mass unit. When it is represented in gram, 16 into 1.66 into 10 to the power minus 24 gram. While gram atomic mass of oxygen is 16 gram. Means that value multiplied with Avogadro number. Similarly, if you select one molecule, that is methane CH4, so mass of one methane molecule, that is 16 AMU. When it is represented in gram, that is 16 into 1.66 into 10 to the power minus 24 gram. While the gram molecular mass of methane is 16 gram. It is little idea about atomic mass and gram atomic mass, molecular mass and gram molecular mass. Next, equivalent mass. This is common formula. Equivalent mass is equal to atomic mass by valency. As valence is a variable one, so equivalent mass also variable one. Next, equivalent mass of an acid, that is molecular mass of acid by basicity. What do you mean basicity? Is the number of replaceable H plus ion given by an acid. Similarly, equivalent mass of a base is equal to molecular mass of a base divided by acidity. What do you mean acidity? Number of hydroxide ion, OH minus ion given by a base. Next, equivalent mass of salt is equal to molecular mass of the salt divided by total valence of the metal atom. Next, equivalent mass of an ion is equal to ionic mass divided by total magnitude of charge. Next, 2 to 3 method is there: hydrogen displacement method, oxide method, chloride method, silver method, metal displacement method. That means mass of the, if we discuss first one, the hydrogen displacement method, equivalent mass of metal is equal to mass of metal divided by mass of hydrogen into 1.008. Similarly, oxide method, equivalent mass of a metal is equal to mass of a metal divided by mass of oxygen into 8. Chloride method, equivalent mass of a metal is equal to molecular mass of that metal divided by the mass of chlorine into 35.5. Silver method, mass of the metal divided by mass of the silver into 108. Metal displacement method, that means mass of metal 1 by mass of metal 2 is equal to mass of metal 1 by equal to mass of metal 2. That means W1 by W2 is equal to E1 by E2. This is a little idea about the previous class of the chapter, that is basic concept of chemistry. Today is the class 3. I will try to give a little idea about mole concept. That is, today we discuss mole concept. It is a very interesting one. So, before going to this chapter, mole concept. What is a mole? So, let us discuss about the term mole. Mark that. Mole is nothing but equivalent to one Avogadro's number. Already we covered Avogadro number, represented by, that is Avogadro's number. Avogadro's number represented by Na is equal to 6.023 into 10 to the power 23. This number of molecules is known as 1 mole. This number of atoms is equal to 1 mole. This number of ion is equal to 1 mole. So, today we deduce some relationship and also frame the question and try to solve one by one. Frame one relation between a mole and Avogadro number, and another two terms. One is gram atomic mass or gram molecular mass, and one is gram molecular volume, GMV, that is at NTV, that value is 22.4 liter. Mark that. Let us discuss one by one. That means, if we discuss about, that is number, this is equal to Avogadro number, equivalent to 6.023 into 10 to the power 23. In case of molecules, is equivalent to gram molecular mass, that is known as GMM, equivalent to gram molecular volume, that is GMV, equivalent to 22.4 liter at NTP. Mark the relationship. I repeat again. That is the number equivalent to 6.023 10 to the power 23. That is the number of molecules, is equivalent to gram molecular mass, that is GMM. It is not a fixed variable depending upon the type of molecule. The last one is gram molecular volume, GMV. It is a fixed, that is 22.4 liter at NTP. So this two term is fixed. That means gram molecular volume and the number. These two term fixed, and this one is a variable depending upon the type of molecule. So if we compare, this one is known as 1 mole. This one is known as 1 mole. Mark that. If we compare, that means 1 mole of a molecule equivalent to 6.023 10 to the power 23 into 10 to the power 23 molecule. Any molecule, if you select 1 mole of water contain 6.023 into 10 to the power 23 number of a molecule. 1 mole of methane contain 6.023 into 10 to the power 23 molecule. 1 mole of ammonia contain 6.023 into 10 to the power 23 molecule. Similarly, 1 mole of methane, the volume of 1 mole of methane at NTP is equal to 22.4 liter. 1 mole of oxygen molecule volume is 22.4 liter. 1 mole of nitrogen molecule volume is 22.4 liter. 1 mole of carbon dioxide at NTP possesses the volume 22.4 liter. Similarly, the relationship between mole and gram molecular mass. If we select CH4 methane, mark that CH4, its molecular mass is 16 gram. That means we deduce a relationship. 1 mole of methane, the mass of 1 mole of methane molecule is 16 gram. Similarly, if we select NH3 ammonia, that means 17 gram. So 1 mole of ammonia molecular mass is 17 gram. 1 mole of carbon dioxide molecular mass is 44 gram. So this is the interrelationship between number, mass and volume with 1 mole of molecule. Similarly, if we relate the atom, also relationship is there. That is, if we select the relationship between the mole with the atom, mark that number is fixed, that is 6.023 10 to the 23. Number of atoms is equal to gram atomic mass. This is equivalent to 1 mole atoms. Mark that, this is the relationship. 1 mole of atom mass is known as gram atomic mass. 1 mole of any atom, if we select oxygen atom, then 1 mole of the weight of the mass of 1 mole of oxygen atom is 16 gram. 1 mole of nitrogen atom is 14 gram. 1 mole of any atom, if we select carbon, then it is known as 12 gram. So mass of 1 mole of any atom is known as its gram atomic mass. Similarly, 1 mole of hydrogen atom possesses 6.023 into 10 to the 23 hydrogen atoms. 1 mole of nitrogen atom contains this number, that is Avogadro number of atoms. Any atoms of 1 mole contain 6.023 10 to the 23 number of atoms. So let us deduce relationship one by one. Then we frame a question, try to solve it. First, mark that first relationship, that is a number, that means Avogadro number, it is 6.023 into 10 to the 23 molecules with gram molecular mass known as GMV, gram molecular mass. Mark that. We deduce a relationship between these two terms. One is known as number of a molecule, that is Avogadro number, and that is known as GMM, gram molecular mass. So first example, that is point 1 for CH4. Mark that. We select one example, that is methane. That means 6.023 into 10 to the power 23 methane molecules, gram molecular mass GMM. 6.023 10 to the power 23 methane molecule weight is equivalent to, that means 16 gram. CH4, that means 12 plus 4 is equal to 16 gram. Mark the relationship. Avogadro number of the weight of Avogadro number of methane molecule is equal to 16 gram. If we select another one, that means second for NH3, mark that 6.023 into 10 to the power 23 NH3 molecule weight equivalent to 17 gram. isolate carbon dioxide, then the weight of Avogadro number of carbon dioxide molecular weight is 34 gram. HCl, hydrogen chloride, hydrochloric acid, the weight of Avogadro number of HCl molecular weight is 36.5 gram. It is the relationship. So from this relationship, let us derive a question and try to solve it. Mark that. Suppose this is the question. Mark that. The relation is Avogadro number of methane molecular weight is 16 gram, or one can write 16 gram of CH4 molecules. 16 gram of CH4 molecule contain 6.023 into 10 to the power 23 molecules. Mark that. I repeat again, 16 gram of methane molecule contain Avogadro number of methane molecule. So frame the question, mark how the question is. Calculate the number of methane molecules. Calculate the number of methane molecules present in 3.2 gram of CH4. Mark that. A question is there. Mark the question. What is the question? Calculate the number of molecules, methane molecule present in 3.2 gram of methane. So by reading the question, one is how is able to frame the relation, then try to solve. Mark the relation. Question is calculate the number and this much gram. From the reading the question, one is able to clear that a relationship with number and gram. So frame the formula, that is answer. That is the number, that is Avogadro number, equivalent to gram, means GMM, gram molecular mass for CH4. We know that for CH4 it is 16 gram. So it is clear that 16 gram of methane molecule contains 6.023 into 10 to the power 23 methane molecules. So from this relationship it is clear that 16 gram of methane contain this number of molecules. So question is calculate the number of molecules. That means if 16 gram contain this one, then 1 gram contain 6.023 into 10 to the power 23 by 16. Or by questioning 3.2 gram contain, that means Avogadro number divided by 16 into 3.2. Mark that. Solving this value, one is able to calculate the total number of molecules present in 3.2 gram of methane. So it is one question from this relationship that calculate the number of methane molecule. Next, from same relation, you deduce another question. Mark that. Question is, second question, calculate the total number of atoms present in 3.2 gram of CH4. Mark that. Same relationship there, but different question. What is the question? Calculate the total number and gram. Same concept is there. Number, that means 6.023 into 10 to the power 23. This is the number equivalent to calculate gram, that is CmN for CH4, it is 16 gram. So same relationship is there. This number of this 16 gram contain this number of a molecule. So previously we calculate what is the number of molecule, what is the total number of a molecule present in 3.2 gram. Let it is 10. So mark that. Let total number of CH4 molecules present in 3.2 gram of CH4, let it is equal to 10. Suppose the total number of methane molecule in 3.2 gram is 10. Then we know that one methane molecule, one CH4 contain two type of atom, one is carbon and one is hydrogen. So one molecule contain 1 plus 4, 5 different types of atom. So if one molecule possesses 5 number of atoms, then according to 10 molecule is there. So total number of atoms present is equal to 10 into 5 is equal to 50 number of atoms. It is the second type of question. Move to third type of question. Same concept is there. Now calculate the total number of carbon atoms present. Next question. Now calculate the total number of hydrogen atoms present. Now question. Calculate the total number of hydrogen molecule present. Same. That is 3.2 gram of methane. Answer. Let the total number of methane molecule, whatever may be the question, always we focus to the number of molecules. So let the number of methane molecules is present in 3.2 gram is 10. 10 molecules is there. Next, one methane molecule contains one carbon atom. So total number of carbon atom is 10. Next question. One methane molecule contains 4 hydrogen atoms. So total number of hydrogen atom present in that wave is equal to 10 into 4. That is 40. Next question. One methane molecule contains 2 hydrogen molecules. So 10 number of molecules contain 10 into 2. Number of, that is 20 number of hydrogen molecules. Mark that. One concept, what is the different way of asking the question? So now from the molecule we calculate from this value, that is number and mass, we calculate the number of molecules, number of atoms, number of each kind of atoms. Now move to calculate number of electrons. Same concept. Number of electrons. So how to calculate number of electrons? We know one term is there, that is atomic number. Atomic number of hydrogen is 1, means number of electrons is 1. Atomic number of sodium is 11, means number of electrons is 11. Atomic number of carbon is 6, means number of electrons is 6. So basing upon this concept, now we also calculate number of electron, number of proton, number of neutron from this data. Mark that how it is. Same concept is there, that is now just modify this. Calculate the total number of electrons present, total number of electrons present in 3.2 gram of methane. Mark that. Same concept. First we focus to number of molecules with that mass. Again suppose number of molecules is 10. Now mark that. Let the total number of CH4 molecules present in 3.2 gram of CH4 is equal to 10. Then we discuss about one CH4. One CH4 contains 1 carbon, 4 hydrogen. Carbon, atomic number of carbon is 6, so number of electron is 6. Atomic number of hydrogen is 1, So total number of hydrogen, total number of electron is 1. As 4 hydrogen is there, total number of electron present in hydrogen is 4. So total number of electron present in one molecule is equal to 6 plus 4, that is 10. So one methane molecule contains 10 electrons. So total number of electrons present in 10 molecule, 10 into 10, 100 electrons. So from this concept, one is able to calculate the total number of molecules, total number of atoms, different types of atoms, then the total number of electrons equivalent to number of protons, so total number of protons also. It is all about one concept between number and mass. Then reverse the concept with another type of question. Now that by reversing this data, that means now select for ammonia. We select for ammonia. That means ammonia 14 plus 3, that is 17 gram. So relationship 17 gram of ammonia contains 6.023 into 10 to the power 23, that is the Avogadro number of ammonia molecules. Mark that. Previously we made a relationship number with mass. Now we have a relationship mass with number. That means, it is example 1, 17 gram of NH3 contain Avogadro number of a molecule. Similarly, example 2, 44 gram of CO2 contain 6.023 into 10 to the power 23, that is known as Avogadro number of carbon dioxide molecule. Similarly, another example, 18 gram of H2O contain 6.023 into 10 to the power 23, that is Avogadro number of water molecule. Mark that. So now deduce the question. From the relation, first thing we derive the relation, then we derive the question, make a question, then try to solve on that concept. So now, in previous case, we calculate the number of molecules, number of atoms, number of ions, number of electron, number of proton. Now we calculate the mass. Mark that from the first one. Now calculate the mass. Means calculate the mass of particular number of ammonia molecule, methane molecule, carbon dioxide molecule, water molecule. Let us discuss one by one. Question is question 1. Calculate the total weight of 6.023 into 10 to the power 21 NH3 molecule. Question is calculate the weight of 6.023 10 to the power 23 NH3 molecule. So first focus to the question. What is the question? Question need what is the relationship between these two? Mark that. So calculate the total mass and this number. So that is GMM, gram molecular mass. First we discuss a molecule, then we transfer to atom. Whatever may be the question, if relate to mass, then focus to molecular mass. Then transfer to atomic mass, ionic mass. Equivalent to, that is number means 6.023 into 10 to the power 23, that is Avogadro number. is the relationship? Read the question, find the relationship. So then we will try to solve this one. So example is for NH3. So NH3 means 14 plus 3 is equal to 17 grams. So what is the formula? 17 gram of NH3 contain 6.023 into 10 to the power 23 molecule. Mark that. 17 gram of ammonia contain this much molecule. Then 1 gram of ammonia contain, that is Avogadro number divided by 17. Then according to question, what is the question? Calculate the total weight of this number of molecule. So reverse the question. Now reverse the data. Mark that. It is 6.023 into 10 to the power 23. The weight of this was number of NH3 equivalent to 17 gram. So for the weight of 6.023 into 10 to the power 21 of this was 17 divided by 6.023 10 to the power 23 into 6.023 into 10 to the power 21. Mark that. 17 by 6.023 into 10 to the power 23 into 6.023 into 10 to the power 21. I mark that. I repeat again this one. Mark that. 6.023 into 10 to the power 23. Number of molecular weight is equal to 17 gram. One number of molecular weight is equal to 17 by 6.023 into 10 to the power 23. Then question according to 6.023 into 10 to the power 21 molecular weight equivalent to 17 by 6.023 10 to the power 23 into 6.023 into 10 to the power 21. Cancel out. It is 100. That means 0.17 gram. Okay. So now calculate the total weight. So the total weight of this number of NH3 molecule is this much. Similarly, calculate the total weight of particular number of, we select to CH4, we select to H2O, we select to HCl, we select to N2, O2, H2, N1. Let us discuss one by one. Next example is second example. Calculate the weight of 3.01 into 10 to the power 22 number of CO2 molecule. So read the question. What is the question? Question is calculate the weight and the number. Question is calculate the weight and the number. So deduce the relationship. That means number is number, Avogadro number 6.023 into 10 to the power 23, and weight, that is GMM, gram molecular mass of CO2, that is equal to 44 gram. So what is the formula? Formula is this number of carbon dioxide molecular weight is this much. So what is the statement? The weight of 6.023 into 10 to the power 23 CO2 molecule is equal to 44 gram. So according to question, this much. So the weight of 3.01 into 10 to the power 22 CO2 molecule is equal to 44 divided by 6.023 into 10 to the power 23 into 3.01 into 10 to the power 22. 2. This one cancel 2. This one cancel 10. That means 22 by 10, that is 2.2 gram. So whatever may be, whether it is CH4, NH3, H2O, O2, N2, Cl, whatever may be, focus to the question. What is the relationship? Number and mass. Then deduce the relationship number, whether it is atom or a molecule or ion or electron or proton. Always focus to number, means 6.023 10 to the power 23. Then GMM, gram molecular mass. Select the molecule, find out its mass, represent in gram, that is known as gram molecular mass. Whether the question is atom, ion, electron, whatever may be, I repeat again, first you calculate the number with gram molecular mass. First you calculate molecular mass, then you transfer to atomic mass. So now a little idea about relationship between number and mass and number. Next we switch over to another relationship, that is mass and volume. Next relationship is, second relationship is relationship between gram molecular mass, that is known as GMM, with gram molecular volume. This is known as GMV. Mark that. First we cover number with mass. Second we cover mass with volume. Mark that. What is the relationship? GMM is equal to GMV. This two is fixed, where this value, that is equal to 22.4 liter at MTP. This is fixed, but this gram molecular mass is variable depending upon the type of molecule. Let us select one by one. First we select, suppose NH3. Mark that. Between 4 NH3. So gram molecular mass is 17 gram and volume is fixed, that is 22.4 liter at MTP. So what is this relationship now transferred to one statement? What is the statement? The volume possessed by 17 gram of NH3 molecule at MTP is 22.4 liter. The volume, if we select second one, is for CH4, that means 16 gram. Volume possessed 22.4 liter at MTP. If we select for CO2, that is 44 gram. Volume is 22.4 liter at MTP. So this is always a fix, but this one is a variable depending upon the number of atoms, so types of atom present in one molecule. So now from this relationship, let us deduce the formula first, then question, then try to, so formula is over, then try to deduce the question and try to solve it. So in second case, we relate to GMM, gram molecular mass with gram molecular volume. Concept GMM with GMV. GMV is 22.4 liter at MTP. So first we select CH4. Question. What is the question? Calculate the volume possessed by 1.6 gram of CH4. First we select methane. Calculate the volume possessed by 1.6 gram of methane. So first read the question. What is the concept? Read the question and find out the relationship between the two terms. Which two terms are interrelated? Mark that. Calculate the volume. One term is volume, means GMV is equivalent to 22.4 liter at NDP. 1.6 gram. Gram means GMM for CH4. That means 16 gram. This is the relationship. That means the volume possessed by 16 gram of methane molecule is 22.4 liter. So come to the question. If volume of 16 gram is this much liter, what is the question? What is the volume possessed by 1.6? Therefore, the volume possessed by 1.6 gram of CH4 is equivalent to 16 gram this much. So 1 gram, that is 22.4. That is 22.4 by 16 into 1.6. So solve this one. This is equal to by 10, that is 2.24 liter. Mark that. So the volume possessed by 1.6 gram of methane is 2.24 liter. Similarly, select another molecule. Mark that. Calculate the volume possessed by 1.7 gram of NH3 at NTP. Mark that. So same concept is there, that is mass and volume. GMM with GMV for NH3 is equal to 14 plus 3, 17 gram. That is 22.4 liter at NTP. Now relation is there. So volume possessed by 17 gram of ammonia is 22.4 liter. So question is, therefore the volume of 1.7 gram of ammonia equivalent to 22.4 divided by 17 into 1.7, cancel out 2.24 liter. Mark the concept. Whatever may be the molecule, there is no change in the concept. Always concept focus to two terms, that is mass and volume. Now we make an interconversion, volume with mass. Mark that. Now reduce the relationship. Previously we go through mass with volume. Now GMV, that is 22.4 liter at NDP, it is fixed with GMM, gram molecular mass, which vary with the formula. Same thing is there. Let us discuss another one, that is N2, nitrogen. Example 1, for nitrogen molecule. That means the weight possessed by N2, that means the atomic number of nitrogen is 7, atomic mass is 14, as 2 nitrogen is there, that is 28 gram, the weight of 28 gram. Next for nitrogen, we have to focus the volume, that means 22.4 liter of nitrogen molecule, weight is 28 gram. The weight of 22.4 liter of nitrogen molecule is 28 gram. So friend, the question, what is the question? Before another example is there for H2O. That means 22.4 liter of H2O molecular weight is equal to 18 gram. Select another one for HCl. That is 22.4 liter of HCl molecular weight is equal to 35.5 plus 1, 36.5 gram. Mark that. Then we frame the question. In previous we calculate. What is calculate? First we calculate the weight. Now calculate the volume. So question is calculate the volume possessed by question 1. Calculate the volume of 3.2 gram of CH4. Mark the question. Question is volume and mass. That means GMV, that is 22.4 liter, and mass, that is CH4 molecular mass is 16 gram. So question is calculate the volume. That means 16 gram of CH4 has a volume of 22.4 liter. Then 1 gram of CH4 has a volume 22.4 divided by 16 liter. Then according to question, therefore 3.2 gram of CH4 has a volume 22.4 divided by 16 into 3.2. On simplify, that is it is 32.10. Is 2 is equivalent to 4.48 liter. Next, select another example. Now select CH4. Now select carbon dioxide. What is the question? Calculate the volume of 8.8 gram of CO2 molecule. Read the question and focus to two terms. One is volume and one is mass. That means GMV, that is 22.4 liter at NTV. That is carbon dioxide, GMM of carbon dioxide, that is 44 gram. So, write the statement, 44 gram of CO2 has a volume of 22.4 liter. Next, 1 gram of CO2 possesses a volume 22.4 divided by 44 liter. Therefore, question 8.8 gram of CO2 has a volume is equal to 22.4 divided by 44 into 8.8 means 88 by 10 2 is equal to 4.48 liter. Mark the concept. So never confuse, not necessary to by heart the relationship. Only you find out the three terms is there. One is number, that is Avogadro number of molecule, number of atoms, number of ions, number of electrons is equal to gram molecular mass. It is not fixed depending upon the formula. And last one is gram molecular volume at NTB or STP. It is fixed, that is 22.4 liter. These three terms are interrelated with mole. That means 1 mole equivalent to Avogadro number of molecules, Avogadro number of ions, Avogadro number of atoms. 1 mole is equal to mass is its molecular mass, and 1 mole of that molecule possesses at MdV a volume of 22.4 liter at MdV.